Hello. Welcome to this topic, which sounds like someone's master thesis. I promise it won't get scientific, and it will be quite opposite, rather practical use of large language models and how to use them to solve real business problems. So uh, I'm. It's actually, it's probably the biggest crowd I'm ever spoke in front of. So quite nervous. Sorry for this. I hope that when the slides progress, I will become a bit more comfortable speaking about this. So the topic, the title of this talk sounds like super complicated, but in practice we will be talking about few things and all related to artificial intelligence. So we will be talking about local large language model deployment and usage. We will be talking about how to do it fast. We will be touching how to do not just generation, but as well text translation as well locally. We will be briefly touching on how to use large language models for the data and text validation. And most importantly, we will be basically doing all of these things to at scale in solving real business problem. So I want from the very beginning to be like super transparent for whom this topic is for and for whom it is not for. So if you are on this side, so you are like using OpenAI APIs, you can afford it and you're happy with it, then probably this topic it won't be for you. But if you are like rather broke, like we were at the moment when we were implementing this project. So for us, like at least even like €1,000 were like insane money. So we needed to find like more efficient and money efficient solutions to do the things. As well, this topic might be for ones who cannot use or don't want to use public large language models APIs due to the privacy reasons or any other reasons. If you don't want the data to leave like your environment, this is as well for you. This is as well for you if you are interested in general, like how to use large language models locally on your machine, on your server. As well, this is for someone who will be interested in local translations. And lastly, for ones who are interested in how to do local large language model deployments fast. So very shortly about myself. As already introduced, I am my daytime job is senior analytics engineer at Beyond Analysis. I'm as well founder and CEO of Scores.lt. This is like the AKA better requisite, and more recently, I'm also the creator of probably the best like Lithuanian weather app, Oryx. So the slides and all the code and all the links, everything is here. This slide as well will be presented at the end, so you can first listen and decide if you interested in taking picture of this and exploring more. So let's start with the business problems, so like what we were actually trying to achieve with this, because the quite often I just hear about like fancy technologies, but like what exact like business problem you are going to solve with that technology. So we had a very practical business problem, and we like just applied all of this to solve that. So first, like just few words about SCOTUS. If you have not heard about it, this is, as I mentioned, the better requisite. So we aggregate data from a lot of public data sources. We combine that data, enrich it, and present it to the public, together with sorry, with quite many like innovative tools on how to explore the companies and how to find the needed information. And our main traffic source is search engine. So usually people don't come to SCOTUS or Requisite or any other similar site just to come to the site. You know, like they come to some news website or I don't know, some social network. They usually come when they are interested in one company or another company, and they how they reach it. So they basically drop company name into the search field and click first few links on the search page. And our majority of the traffic is following the same pattern. So basically, the search is main traffic source for us. So in order to get more traffic, if you want to grow, you know, we need to be more relevant and to be positioned higher than the competition, so that because people usually rarely go to the second page. Mostly, most of the people just click first few links. So how to increase the position? So this is search engine optimization task, and the search engine optimization in a nutshell is basically you want to achieve like two goals. The first one, get indexed, and then the second, improve the ranking. So this getting indexed, usually it is like fast process. So you just publish your website, put few links somewhere, and eventually Google will pick it up and will index it. And if you have just, I don't know, few pages, it will be rather fast, because we had 500,000 pages. For us it took close to 1 year until we got like fully indexed. And when we got indexed, our position in search was quite low. So we started exploring like how can we improve our search position. And basically, to improve the search position, like most, of course, Google doesn't disclose the algorithms, like how to do it, but most research and most information, they they talk about like three things. So first, you need to provide like relevant content. Then you need to offer like great customer experience, and then you need to be like reputable like data source. So if you nail all these three, then likely you will get ranked higher than the others. So so basically, how we were hacking Google search. So first, not sure visible, yeah, probably visible. So the first was easy part. So how to make us fast, because the great customer, great user experience from point of Google, like it is this Google page speed index, which takes into account the speed and the colors and layout and so on and so forth. So we basically, I think, perfected that. And still, our rankings were not like growing at the pace we wanted to achieve. So then we were exploring like what else like can we do, and then we came up to conclusion that we have we have like relevant content for the humans who are interested in the company. So we have plenty of data, plenty of beautiful data, and basically no text. So when you try to imagine how Google sees your website when you're trying to index, so it just opens and it sees like some tables, some random numbers, some JavaScript with some charts. So it just doesn't understand what this page is about. So we raised the hypothesis like that probably the reason is that we don't have enough textual information, so that So we need somehow to take this and convert it to like readable text. And AI was already at booming, so so we just made a decision that okay, let's try to use large language models to generate descriptions about our data to have more text on our website. And and because yeah, we as I mentioned, broke at the time, we needed to do it like as cheap as possible, as well, preferably as fast as possible, and so that it would have like at least decent quality. So our first project like took like probably like 3 weeks, and then at that time we achieved like generated the first batch of descriptions for our website, and it was around like 4 seconds per description. We had around like 120,000 descriptions to generate, so this whole process like took 1 week, like fine for like static data which doesn't update like on daily basis, but yeah, suboptimal. So yeah, like we were iterating and exploring this solution to improve the speed, and in roughly like half a year we achieved sub-second per description milestone. So we had yeah, whole process like took roughly like 1 day to generate. And the slide was initially at the very end, but I just decided that I would move first a bit up. So this was the final result. So we had like financial data originally, and we converted that to, I think, like quite readable text. I never like assumed that the person will be reading this text. So this was like originally designed to be like just for the search engines, because my assumption about world is that everyone is is like me, even though I know that it's not. And my assumption is that the people are easier for people to read the table than this one. Even this like and this are like rather like the same thing. So how we achieved all of this. So I will stop a bit on this slide, which I call like Broke Dev's Guide to AI Solutions, and this one is a little bit a little bit outdated, but I think it's still like serves the purpose for the message. So. So all the solution was done like roughly a year ago. So in AI landscape, a year is like an age. So everything like changed from that time. So if most companies, most engineers would try to solve the same problem right now, it would be significantly more simple, because you could just use like OpenAI's 4.0 model and generate the financial description in Lithuanian like instantly. You don't need to do translations. The 4.0 speaks like writes in Lithuanian already quite decently. That was not the case a year and a bit ago. Another problem was that for us at that time, the cost of generating all of these descriptions, like at this scale, was too expensive. So we were looking at local AI models. And most local models, they are significantly smaller than these big one cloud providers. And because they are smaller, this means that they are most of them, they just generate English text. So if you use local large language model, then the output will be in English. Then you need to do the translation. And initial assumption was, so what's the problem? We generated descriptions using locally, and then we will use API service to translate that using the Google Translate or DeepL. And I don't know if you ever encountered this, but this online translation is like horribly expensive. So if we would look like at 4.0, for example, pricing, so we have I think today it's like $2.50 like input and around $10-15 per output per million tokens. For translation, the price is still the same, and it's like $20 for 1 million characters. So this is not like tokens. So and this is like really becomes like really expensive exercise. So we're exploring how to do the translation locally. So currently, the cost it would be if we would generate just English, this like 6,000. It's a bit here just for the presentation. We definitely now can do it cheaper with cloud service providers. But at that time, we just assumed that if we generate English text and then we would use cloud translation, then the total cost would be around this. And then on our end, we implemented this with roughly like €1,000 budget by just buying graphics card. So the technical architecture quite simple, even though it doesn't look simple, and it haven't started like this complicated. This is the end stage where we had the sub-second speed generation. Originally, it all started like on one single machine. Originally, it started with 2 scripts, one generate script and one translate script. After first batch was published on our website, we received a lot of emails and a lot of complaints what kind of BS we published. So we needed to create new script, which would be the validation script. So before publishing, we would want to validate that the text makes sense. So why then free machines? Why we use like free machines? So I will go into more in depth into each of those scripts and how they are implemented, but just very briefly. So validation and translation scripts, they are basically identical, except the prompt is different and slightly the data structures are different. But in general, like 95% of the code is identical. So I will touch about backend, which we used for local large language models inference later. But for now, the process was basically like this. So we were fetching financial data from the database. We were combining that financial data with the prompt. We were sending that prompt to local large language backend. Then we were receiving a generated description. We were storing that description into the database. We were then translation worker were waiting until some translated descriptions were in the database. It was checking, it was picking those up, translating, writing it back to the database, and then the validation script ran as well in parallel. So it just validated if the description makes sense. So technically, you can run this on single machine. Since we had free machines, we used all three, which significantly improved the speed. So this slide, I think, is one of the most important of the slides. And if you will be able to take only one message from this presentation, then take this one. So if you are interested in local large language models and you want performance, then use Aphrodite engine. So it is like quite not very well known engine, but during the search of the speed we encountered this engine, and basically what this does. So if you take the methods from the first presentation of today, the keynote, and use the Hugging Face transformer models, and you would load it to Python, and you would generate. And if you have, like for example, decent GPU, like 3090 or 4090, or I don't know, if you are rich, 5090, then then you can expect around like from 100 to 150 like tokens a second throughput that uh, from that method, and it's fine if you are uh, if it's fine for like agent. So if you want to chat with the thing, that speed is completely fine, but it's not fine if you want to generate hundreds of thousands of text items and to do it very fast. What this model does is I don't know how it works because I'm not an AI engineer and I'm not even the Python engineer, so I have no idea like what I'm doing in Python day, talking about AI, but as well, I don't need to know how car works to drive the car. So it does some kind of magic that you can send at a time quite no you basically can do batch processing in there. So you, instead of sending one prompt, you can send 50 prompts at the same time, and it does generate them all at the same time. So we are achieving throughput of around 1,000 tokens a second. And Aphrodite website, I think, even advertises that on single 3090 GPU you can achieve even 3,000 tokens a second throughput. We were not able to achieve that. It's most likely a synthetic benchmarks or very small efficient models. But yeah, for us, even 1,000 tokens a second throughput was quite impressive. Now I have bunch of like code snippets again. All of this is basically Python 101, so quite basic stuff. So when you have your backend running, so basically the setup, just I haven't mentioned, the setup is like super simple. It's just like two commands. One is just install the engine, and the second just run the model. And this one is just a model name from Hugging Face. So it automatically downloads the model, and it opens up a backend API where you can do the batch processing and sending your prompts. So as I mentioned, yeah, I will be skipping a lot of these slides because this is, as I mentioned, Python 101. Not much to talk about. I will just maybe stop on few things. So one, the batch size. So when you have this Aphrodite engine, means that you can send, instead of one prompt, you can send a lot of prompts at the same time. The number of like how many you can send, it's I think trial and error. So the smaller number you will send, the slower it will be, but at some point it will choke. So it will start skipping some prompts, throwing some errors, and means that it's just exceeds the capacity, like what it can achieve. So I think the best way, if you would be using like this method, is just to do some trial and testing. So you do 100 prompts at 10 like batch size, do again 100 at 20, 100 at 30, and then you see where is the best performance. Then when the model is running, so the generate function is like super simple. So we just have some system prompt because we are interested in generating the description. So we told, imagine like you are a professional business writer. And another thing, we wanted that these descriptions would be somewhat different, so that not all of them would be like the same. So we used a random seed to bring some variety into this. Then the actual prompt, again, this is mostly our use case. If you would be doing something similar, then you can find your own way, but the prompt is basically one of the most important parts, because that defines like how this description will end up. We were just basically saying that, generate financial description, use only provided data. Here is the data, and here are some basic requirements that the model should follow. Then because we were doing batching, so of course we needed to use everything like async functions to process everything concurrently. And as I mentioned, the generate and validate scripts are like basically identical, except for the prompt part. So for the prompt, we were using like slightly different one. So we were interested in just can you take this data? Can you take this text, compare one to another, and give us one word? Like, is it like correct or incorrect? And here I think important message is don't use the same model for validation which we used for generation, because if one made a mistake, it's very likely that the validation will do the exactly same mistake. So we used a different model to do validation, and model selection for generation was easier than finding the model for validation. Specifically, if we wanted just single word like correct or incorrect, that's it, like one word. Most models were quite hesitant doing this. So most of them, no, the data is not correct because or yes, this data is correct. No, like, yeah, what like single word. So it's again some trial and error to find the correct model which will fit the purpose. So finally, we generated all the descriptions. We went through the validation. How we did it, basically, if it marked incorrect, we just deleted them and generated them again, and that's it. We ran one more validation on those new, and if it was again marked incorrect, we just deleted, and then we stopped at this point. We have not generated those few leftovers. In general, like it was 10-15% of descriptions generated were marked as incorrect. So then we, at this point, we already had English description, so we needed to do the translation. And with translation, we faced new set of challenges. So there are plenty of large language models right now. So Hugging Face, if you would go to find large language models, it's quite easy or hard to do, but because you have to choose from like 10,000 models. When you do the translation, and especially from niche, from popular language, but to the niche language or vice versa, then selection of models becomes significantly narrower. So you are choosing from 5 probably. And we tested all of them. So these 5 were somewhere from Facebook, so it's like MBART, somewhere from Google, like MATLAB or MT5. None of them were even close to be like decent or good. It was like extremely poor quality. Eventually, we found out that there are model family from Helsinki NLP called like Opus MT or Marian MT sequence-to-sequence models. So these sequence-to-sequence models, they basically, the definition already says what it is. So you take one sequence, you put that sequence to the model, it spits another sequence. So they are most of these other translation models, they are like multilingual. So you can do from English to Lithuanian, from Lithuanian to English, from English to Chinese, or whatever. These sequence to sequence, they are just one way. So you need separate model to do from English to Lithuanian. You need separate model to do from Lithuanian to English, and so on. But what we found out that results were, even with the base model, were very, very good, like close to Google Translate and DeepL like level for this. But what we did, we found out that actually fine-tuning the model is not that complicated. So we had like very specific use case. We just need to translate like financial descriptions. So what we did, we paid a little bit to Google Translate and DeepL, and we generated training data set just for our use case specifically. And we trained, fine-tuned this Opus MT model, and the results were like very, very good. So we even ran comparison against Google Translate and DeepL, and the model like even exceeded the results of those ones. So running the model locally, which weighs like what 700-800 megabytes, and achieving like same level of performance like these big service providers were like quite impressive. So for translation model, this was becoming like new bottleneck for us, because we already find the way how to generate using Aphrodite engine like very fast those descriptions, but then the translation were very slow. Yeah, so like from those like 4 seconds, I think it was like 1.5 seconds to generate, and then the remaining time to translate. So it took longer to translate. So we were looking as well for the ways on how to speed up the translation process. And the solutions which we found, I have no idea what they mean, and I have no idea how they work, but they work. So what we did, so first, these translation models, they come in PyTorch format. The first boost in performance was converting the models to ONNX format. And conversion was as well a bit cumbersome, but I have posted the code in this Git page if you will be interested in converting the model from one format to another. Then we use these graph optimizations, whatever that means. Then we used no-grad inference, whatever that means. Then we used greedy decoding strategy, whatever that means. And then even though it doesn't really support the batching, so to generating like multiple at the same time, we still had this in the code, and that is boosted this performance even more. So we were like able as well to achieve like quite decent translation performance applying these strategies. Just as well, quick note on translation process. So the sequence-to-sequence models, they again, as the definition says, it takes one sequence, outputs another sequence, and most input-output data, training data, is based on the sentences. So you need to put one sentence, you get another sentence. Like put Lithuanian put English sentence, get Lithuanian sentence. So and the generated descriptions were like text. So what we were doing, we were splitting description into the paragraphs into sentences, feeding sentence by sentence to the model, and then combining it back to the text. So that was the final solution. And then service orchestration. I think this one as well is just Python 101 stuff. So did it work? I think the main question. So yeah, at this point I had to it was this slide. So what we ended up. So we finally generated all the descriptions for like around like 120,000 Lithuanian companies. There are around 220 active businesses in Lithuania. but half of them, they don't provide any financial data, and though they don't have any employees, so what to generate, what to generate about this company. So it's just like, yeah, we don't have data about this company. So for those where we had data, we generated these 120. Then we replicated this process not only just for financial descriptions, but as well for staff descriptions. So what are the employee trends? And then finally, we replicated this to generate generic description about the company. So then, as of today, we have quite a lot of machine readable, technically human readable as well, but like for our use case, like machine readable text, and did it work? So maybe I don't know, because we did. It would be extremely difficult to do like A/B test on in such an example, because the results from the solution till the end, it might take months, days. Like it's very hard to say how Google like behaves. So and as well, we had like not only this, but the product, and in general, the Scoris is like quite evolving product. So we like using like different tactics and techniques and developing the product like in general, but like looking from like super high picture. So we implemented this roughly a year ago, and our average position was around 12. Today we have average position around 7. And impressions to the website and the traffic to the website increased quite significantly. So I believe that it helped, but I don't have like very hard evidence that exactly this helped to achieve our results. And that's basically it. So like if again, if you don't remember anything what I talked about, so I think just like 3 main messages: that Scoris is probably the best Lithuanian business information website. Aphrodite engine is probably the best local large language model inference engine for mass generation and speed. And then Opus Marian MT sequence to sequence translation models are as good as DeepL and Google Translate, and especially if you fine tune them for your specific use case. So, yep, thank you, and I'm open for the questions.
Is Aphrodite any different from VLLM? Have you compared those frameworks?
It's based on VLLM.
Okay, so performance is like very similar.
I have not tried like this bare bones VLLM, but I know that it is one of it is used based on that one.
What drove you then to the Aphrodite rather than VLLM?
I don't know. I first found out about Aphrodite engine than VLLM. I don't know how, but yeah.
Okay, thank you.
Hi, so I want to ask, what's the context size of financial data that you were sending? Did you encounter any context size limits and that you can pass to the LLM? And the follow-up question is, how did you maintain the numbers accuracy with the context data and the output from the LLM?
Yeah, so it was a lot of, again, this trial and error. We pre-processed data heavily before sending it to LLM engine. So initially we just sent like raw data. Here is the revenue for this year. Here's the revenue for that year. Do your magic, output your numbers. But we encountered that it was for LLM was very difficult to compute the percentage sizes, the increases, decreases to understand. So we were pre-processing like quite heavily that this is the revenue in these units, this is the percentage growth. So like and we combining in this JSON side, like JSON format. We then the context size. So input message was on average, I think, was 1,500 tokens, and output size was around 450 tokens. So that's like roughly the challenges which we had originally. We tried to do like pre-processed and send the data already like rounded. Here is the revenue, like 20.1 million euros. And but we found out that these LLMs were a lot of mixing, like millions becoming thousands, thousands becoming billions, etc. So the best result was we don't round, we just send full unrounded number. Like here is like 20 million with like a lot of digits figure. Then it produced the best results.
Any particular reason why you chose to translate from English instead of trying to generate straight, Lithuanian descriptions?
So as I mentioned at the beginning, you can do the straight generation in Lithuanian if you are using OpenAI API like service for all model or something like that. Then you can generate in Lithuanian quite fine. If you will be using local large language models, then good luck finding the one who will generate in Lithuanian. So most of them are rather small models, and none of them generate Lithuanian, or they kind of do, but you don't want to use those results. So.
Anyone else?
Where did you get your source data for, and was it structured when you got it?
So we have plenty of data. So Scoris is this Lithuanian business database. So our main business is collect data from public data sources, to aggregate it, enrich it, and store it. So the only thing what we have is high quality structured data. So but we did not have textual like description of this. So that's what the purpose was.
But do you scrape it from the internet or somehow get it from?
No, it is open data. Most data about like Lithuanian companies is publicly available. The problem is that it's available in like countless data sources. So some are in tax inspections, some are in Sodra, some is the state registry, and so on and so forth. So the main challenge is to how to combine it in a proper way, clean up and maintain the good quality.
So you mainly get the information from Lithuanian government entities, yeah?
Yep.
Yeah, okay, thank you.
Any other questions?
Thank you. Yeah, so I was wondering, how did you find out that this solution might affect the ranking in Google?
So we were just reading countless articles and discussions and trying to find out how the Google search algorithm works. And this was our own conclusion based on all publicly available data. I don't think that we were much off, especially given that currently, if you try to Google search anything, you will likely first encounter AI-generated text rather than human-generated text. So it seems that everyone is doing that, even though I don't think it is good practice. But yeah.
And also to add on that, is it the landing page only, you think, or all the pages?
So how our website is structured, so it is no landing pages, of course, just our welcome. This is super nice product, but then you have search field and the business catalog, and then each company has individual web page. So we were mostly interested in those pages. So when the person will try to look for I don't know, some company XYZ and would enter that company name into the Google, then they would get on top not our like main landing page, but that company page where they can already find directly that information. So we needed to generate the description for each individual company for their individual data.
Thank you.
You mentioned quite a few times that this was purposely for some optimization, but you also received feedback from your customers that like what type of you are generating. So at the end of the day, do you think that it brings any value to your end users?
I don't know. Like, would you read that description? I don't know. I won't. so, so I don't know. So somebody definitely reads them. For sure, the business owners who like when they see their company, they of course read that description. So at least we get one reader for each company. But I don't think that most of the business like our users read that.
So I know that from personal usage, when you type the company name in the Google, always the requisite pops up. So I found out that if you put the scores next to it, and also you posted after a while, you get the scores CEO. So it was a little bit hard to find the data, but it was useful. So my maybe question would be, in a theory, would it be much cheaper to DDoS the requisite instead of building this?
I don't know. I
No
don't
need
know.
to answer.
Yeah. We have as well plenty of requisite keywords in our you know page.
So assuming that you continue to regenerate these descriptions, do you do it now on like incremental basis, or is it batch refreshes or a full refresh every now and then?
Yeah, so we try to do it only for a rather static data. So means that if the data updates weekly, monthly basis, we don't want to generate this every month because it's still, even though it's like in one day, it's still like compute intensive process. So we try to do like mostly like this financial data, which updates only on the yearly basis. So when the company publishes such financial data, we generate the description. We don't need to generate for the next year than we do for employee numbers, but as well, we don't use monthly numbers. We just use annual averages in that case to reduce this. So we do it right now, like I think 3 times a year to generate like on average.
Thanks.
So you have a new weather app, right? So did you think of moving this and using it over there? Today it's a nice weather in Lithuanian, or some description of.
Actually, it uses AI generated weather descriptions. So check it out. So yeah, but I'm not using this model to generate that. We already got a bit more affluent than we initially started this project, so we can now afford to use the OpenAI service as well.
I think we ran out of time for questions. If you have any more questions, you can post it on Discord. So thank you very much, Antanas, for your talk.
Yep, thank you for coming.